Hello and welcome to my talk, BabyBERTa, Learning More Grammar with Small-Scale Child-Directed Language. I'm Philip. My collaborators are Elior Sulem, Cynthia Fisher, and Dan Roth. The story starts with transformers that have recently revolutionized NLP. These models tend to be very large, very deep, and when trained as masked language models, they essentially predict the tokens that have been masked in a sentence, given their context. These are extremely powerful, and we wanted to know if they have the potential to answer questions outside of NLP, such as language acquisition research, where we ask questions like, how do children acquire the grammar of their native language? What is the contribution of language exposure and conceptual knowledge? And in NLP, we ask very similar kinds of questions. So how to build systems for learning and using natural language data, how much supervision is necessary. This is an interdisciplinary project that was tackled by two groups, one at UIUC and another at Penn, specializing in the acquisition and NLP side of the project, respectively. The challenge, as we saw it, is that GLMs are trained on billions of words, and this is not human scale. And also existing corporate benchmarks are unsuited for questions in cognitive science when we're talking about humans. Specific questions then are whether TLMs can scale down to psychologically plausible corpus sizes. How much grammar can TLMs learn given only input to children aged 1 through 6 years, the time range during which children learn language? So on the way, we made available NLP tools to researchers outside NLP. So we made available a lightweight TLM trained on a small corpus of child-directed input, which we call BabyBERTa. We also made available a test suite for evaluating the grammatical knowledge of that model, which we call Zorro, and both are publicly available online. The language data, which we used for our project, comes from 3 domains, each appropriate to a different age range. The first is AO Childers. This is a corpus of transcribed speech to children from the Childers database. And this particular corpus is American English, child-directed speech, where the transcripts are age ordered, therefore AO. And an intermediately complex corpus is the AO New Zealand corpus, which is speech, actually is written language in the form of news articles to middle schoolers. And then some control corpora of Wikipedia articles. And these are, of course, written text to adults. And you can already appreciate they differ wildly just in the number of words per sentence. There are 3 to 4 times fewer words per sentence in child-directed language, at least in our corpus, compared to Wikipedia. There's also way more questions. Half of all sentences are questions, whereas there are virtually no questions in the remaining corpora. When we developed BabyBERTa, we had a couple of design considerations in mind. So the first is that we wanted a state-of-the-art TLM, and at the time that was BERTa, which was trained using the MLM, the Masked Language Modeling Objective. But this model is huge, so we wanted it to be accessible to researchers without access to high-performance computing resources. So we scaled it down almost 100-fold in the number of parameters. We also wanted it to be optimized from grammatical knowledge acquisition, and specifically that meant that we do not unmask. That is, we keep all the masks in the inputs. And this was done so that the model learns abstract knowledge. So rather than given the answer in the inputs, right, we never give the answer in the inputs. We always predict tokens that are masked and never unmasked. Hyperparameters were extensively tuned and identified by tuning the model on an MLM task on a held out portion of the child-directed corpus. To evaluate the model, we developed Zorro. This is based on BLIMP, a benchmark of linguistic minimal pairs, which is used to evaluate the grammatical knowledge. So it differs from BLIMP because it's targeted specifically for smaller models with smaller vocabulary, and the content words are essentially chosen such that they must occur in our corpus of child-directed input, and they must also occur with equal probability in the other corpora that we use, so that when we compare models on these corpora, we know that different performance isn't due to any word frequency differences between these corpora. Our Zorro test suite is enormous. It evaluates 13 syntactic phenomena, each of which has potentially more than one subcategory. So if we zoom into the first phenomenon, determiner subject agreements, one of the paradigms consists of 2,000 pairs. Each pair consists of a well-formed or not well-formed sentence. So you can see that "look at this happy piece" is a perfectly well-formed sentence. And the not well-formed counterpart is "look at this happy pieces." How do we evaluate these models? So it's essentially a forced choice task where each sentence in a pair is scored using holistic scoring. So in this method, the entire sentence is fed to the model, and we simply compute the sum of all the log losses at every token. And then whichever sentence has a lower loss is judged to be the acceptable sentence. And given that there are two options, random guessing would give you baseline accuracy of about 50%. And we also made sure that a word frequency baseline, one that predicts grammaticality based simply on word frequency, achieves no more than 50%. Our first experiment compared the performance of our best BabyBERTa model out of 10 to the original Roberta base, trained on 30 billion words. And strikingly, we find that we're well within reach, only shy half a percentage point. And this was quite a success to us. We did additional experiments where we simply reduced the amount of training to the big Roberta base model. We included a model pre-trained in the literature on 10 million words of Wikipedia, so grammatical performance of these is substantially less, and then a model trained only on 5 million words of child-directed input, even less. And then strikingly, we found that a BabyBERTa model, identical to the one shown in purple, but here in red, differs only in the fact that it does use the original unmasking strategy. That is, it does predict unmasked words. And this model performs considerably less, suggesting that the removal of unmasking, so essentially keeping all the masks in the input, is enormously important for performing well on this grammatical test suite. There's other stats we can use to compare our best BabyBERTa to Roberta. So not only do we achieve comparable accuracy, but the number of GPU hours to train it is enormously reduced, as well as the number of parameters and words. There's a number of additional experiments that we did, for example, comparing domain. The one that I want to show you today for the sake of time is one in which we fed a concatenated corpus of AO Childis and AO New Zealand to the model, and simply compared performance to a model trained on the reverse. So training in reverse order on that data sets. And the idea here was that if you start on input with child-directed language, that might scaffold learning such that you might end with higher performance at the end. And indeed, we find that that is the case. But of course, crucially, we require control experiments. So we want to rule out the possibility that the reason we see this increase here at the end is not due to training on AO New Zealand last here in blue. So we essentially repeat this experiment, but simply replace AO child with Wikipedia, and we don't find that this is the case. So we've ruled out this alternative hypothesis. It's not the case that AO New Zealand last gives you better performance. This does provide some preliminary evidence that starting on child-directed input might provide some scaffolding effects. Now, the conclusions are, well, we've provided some new tools for people in language acquisition research based on TLMs. We've shown that they can achieve good performance on grammaticality tests when given only inputs comparable in quantity and quality to an average English-speaking 6-year-old. And we've also shown that performance is comparable to the original BERTa base that's trained on 30 billion words. And lastly, some preliminary evidence that child-directed language is a good starting point for training, at least when there is not a lot of data available. And with that, I want to thank the co-authors and be ready to answer some questions.